Well, gentlemen, I'm not going to lie, I've been kind of dreading doing this one particular box. It's time for us to begin the end of your project. This is a 96 pill DC solid state amplifier. This has been here for quite some time now. The customer drug this up and hand delivered it to me because it's realistically too big to ship, and then the cabinet itself is in such poor condition that it's so delicate that I don't think it would survive the shipping process to get it home unless we put it in some kind of perfectly blow molded formed case and then put it on a crate and then put it on a pallet. I'm going to say don't judge, okay? Don't judge what's on the inside of this box. The history of this box and who it came from and where it came from and who owns it now and who are the technicians that worked on it in the past. I mean, this amplifier has been around for a long time. This is some very rarefied air. What I mean by that is you'll notice in the radio community there's like 1 billion 2 pills, and there's about 500 million 4 pills, and like 250 million 8 pills. And then, you know, there's probably 200,000 8 pills out there, and, you know, like 100,000 16 pills. And then as you start going up in amperage class and number of transistors, the number of them decrease. It's like there's a few 48 pills out there running around, right? But then it starts to get really finite when you get to 64. I mean, there's probably only ever been, just guessing, maybe 200 or 364 pills ever built, right? And then we have our odd ducts like this, which is a 96, and then there's very few of these. And there's even less of the 128 pills, and then your next option, your step up from there, would be the 320, which is, we know there's only been one, but it was multiple 32 pill. Anyhow, an all-in-one box like this is notoriously hard to get running, and then it's really hard to keep running. It becomes very flaky, and they figured out a long time ago, that's why nobody does it anymore. It's easier to build. Like if you do 128, normally what they do is they do 264s and they'll combine them together. So they'll take the RF, they'll split it evenly, and then they'll recombine it after the amplifier does amplifying things. This is an odd duct. 96 pills, kind of an odd duct. This is the biggest solid state box that's ever been on my workbench, by far. We know for a fact that there are 96 transistors. Each transistor pulls roughly 25 amps worth of shmoo, electronic pixie juice that makes the world go round. My workbench puts out about 1,000 amps. At least the power supply portion of it. Of course, that's supplemented with batteries. This thing here is on a different order. So I could run like a 48 pill comfortably on my workbench. I mean, in theory, right? I've done it many times, especially with one of my own. It can comfortably handle that, not the maximum output, but it can comfortably handle it, right? So that's about 12 to 1,500 amps worth of current. This thing, on the other hand, is a whole different monster. This is, if everything works right when we're done, should pull 2,500 amps at about 15 volts. I don't have a power supply that big yet. And I mean that seriously. I don't have a big enough one yet. Give me a minute. We're going to do this in stages. So, first thing we're going to do is I want you guys to see the inside of this thing that we're working with. I would normally have turned this down. I'm not going to lie, this is a lot of work. This is going to honestly be several $1,000s worth of repair. Period. End of sentence, full stop. You guys know me, I'm not a big fan of doing anything quarter or even a third half-ass. I want to put the best that I can at it. What blows my mind is that this is the ground power pole. This is the hot power pole. These are 300, see, these are legit actual Andersons, huh? Yeah, these are 350 amp, 600 volt. So dual 350 amp connectors. These are 2 pins that slide by each other and marry up, and they just kind of, not this, wrong. Stop it, you dirty-minded bastards. The poles just lay on top of each other and make very little surface contact like that. So we'll say generously saying that this plug has got 600 amps worth of shmoo that it can hold. This box will pull 2,500 amps. To me, that is just what the F, right? The blower at some point, this is not the original setup for this box. I'll show you how I know this in just a second. Yeah, this is awesome engineering. It's technically the right size plug, but we've got this kind of tomfoolery going on. If we zoom in here, we'll see that this wire is almost soldered together. Almost, but not completely. This is 99% of the problems. I call this scab repair work. So what I mean by scab repair is, well, it broke. So now we're going to put the absolute minimalistic amount of repair or time into trying to get the thing running. I'm going to open this for you now. And you guys are going to cry when you see the inside of this. I know I did. I literally spent the last 2 hours standing here looking at this going, should I even continue on any further? Ready? Literally, the longer you look, the worse this gets. This is our 12 volt hot lead coming in from our 350 amp Anderson clip. This is the idea of a grommet, which is a bunch of electrical tape. This is our ground lead here. Once again, gotta admire that beautiful electrical tape. But let's go look at this relay. Let's go in here and take a look at this. This has been on fire. What causes this is in a manual key job. When you step on the pedal, you're doing it while on the mic and it's going whack, 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 whack. And it's arcing it out. This is our input tuner, this here. This is a Jennings vacuum variable, which then attaches to a piece of RG400 coax. And it runs down to here, and then it runs along over to here. So we've got an electrical taped connection here, and another electrical taped connection here, and then each one of the output ports goes to a 80 puff ceramic, so one goes this way and the other one goes that way. So then the RF comes out, runs down this coax line, runs over to here, and then goes to this splitter here. Does it go to this splitter? No. Yes. What? Goes to this splitter here, then gets broke off. Well, then that RF goes to, there's got to be another layer splitter. Yeah, layer splitter here, layer splitter here, and then that RF goes from here to here, what a mess. The longer we look, the worse this gets. I think that's part of the 12-volt distribution system here. But then right next to it, we've got part of the RF. I don't want to do this. Oh man, I don't want to do this. This is our output combiner. This is our final stage combiner. That's the size of my fist, and it's smaller than my fist. I don't know what this is all about or why it's had to be put together in such this way. It is supported by a piece of Teflon block that is held in place by zip ties to keep it from laying down on the board. The output section comes to another wonderful electrical tape creation joint that is also attached over here to our vacuum variable here. So we adjust this, and this is how we add capacitance. I guess this is our inductor tuner at whatever random length this is. This is not a tunable length. This is just what it is. And how it affects everything as it goes by out the cabinet, affects whatever it's going to affect as it goes by and goes out the cabinet. These are our beautiful 12-volt hot connections, which look like they're held up with, what is this gauge wire? This is type MTW. That's 2. These are ground leads that are supposedly going to, I guess this is 218, but then there's no ground leads over here. They got it soldered directly to the board over here. This whole bank of combiner and splitters is abandoned. These two here. But then we come down here, and that same bank is being utilized. There have been a lot of technicians inside this old girl. The lid has been heavily modified at some point. I don't know what all used to be here, but this is cardboard. Or very, very thin particle board. Or is that Lexan? That is a piece of plexiglass with the paper backer still on it that's got 2 square holes in it for the blower. It doesn't really matter because we pressurize this enclosure space, and this is our vent pocket. This is what lets the air actually escape. So I know that that's really shiny and kind of blue looking on camera. This is less than 1/4 of an inch of opening. Look at this. So all the wonderful air cooling, and you have to think how much energy is being imparted to this thing. All of its wonderful possible chance of not getting too hot provided to it by this giant amount of blower motor, which does work, by the way. 100% of that air comes down here to less than 1/4 of an inch worth of opening, has to make a hard 90 degree and then somehow find its way out through the heat sink. And then at the very back of the heat sink, they've got holes about the size of my pinky all in a row across the heat sink. This is the way they did it back in the day, right? So we're not going to judge too awfully hard. We're not. I cannot jump directly into the repair of this until I know that I have the ability to run this, right? So this video is going to take a hard break to the left here in just a second. Like, why? What is, these are just floating around. Oh, it's 12 volt. It brings 12. This is a piece of Romex house wire. This ground strap here is really cute. This ground strap runs all the way down the length of the board. They've got another one over here. This comes down to a strap. It's down here. And I guess this is the 12-volt ground strap or cabinet bond. So every hole on the side of this cabinet has been hog and egged and wallered out as best that it possibly can. This doesn't fit into the normal form of things that we're used to working with. So today I went down to the cabinet get in place, or the metal get in place, and I bought some nice flat aluminum. Now what we're going to do is we're going to make the cabinet bigger. We're going to make this cabinet a little bit easier for us to work with. First, we're going to make it modular, okay? So we're going to take a bunch of flat plates and some angle aluminum, and we're going to build a new box. This aluminum cabinet is broken in spots. Like the front of the cabinet is literally got a crack that runs all the way down the face, and it's held together with duct tape, okay? The same thing with the back. All the holes on this thing are completely effed off. It's too far gone for me to want to do anything with it. And then we have our ventilation issues. So I told the owner of the cabinet, or the owner of this amp, that we were going to take it from 41 inches and we were going to extend it to 44. That's twofold. One, it allows us to have more room in the front so we can get the air to wrap and turn and increase our air velocity. More air velocity means more cooling. But the other thing is I want to take, because we're going to strip this completely down. We're going to strip this like 80% down. There's so much bad here that my brain can't unsee the nightmare that's going on here, right? We're going to take the board here, we're going to slide this down and get this away from the back wall. We'll extend the phenolic, and we want to create a small pocket, maybe an inch or so, 2 inches here in the back, to where we can have the air pick up velocity, and we'll have a very quick low pressure drop here at the back of the cabinet. We'll take and notch out the back of the cabinet so it's a straight exit. But there's a reason other than cost. Cost is part of it. There's a reason that on our modern cabinets we have this spot back here. It helps a lot with velocity and airflow. Well, we don't have any of that going on here. We've got the heat sink right up to the edge of the cabinet, and then we don't have a decent seal. Here's the funny part. Let's go down here and look at this. Let me shine some light up in here for you guys to see this. We have almost the same amount of gap at the back of the cabinet that we have at the front of the cabinet for airflow. So even if we were to get this thing running, it wouldn't be for very long. Look at this. I mean, that's a significant amount of space here at the back of the cabinet. So it wouldn't be running for very long because most of the air is actually squirting right out the back of the cabinet. Air is getting blown down and it's just coming right out of the back of the cabinet. So the parts are sitting in here cooking. The owner of this amplifier did make a small mistake that we're going to have to go back and rectify. They took all the Toshibas out and they put 2879Cs in this. And the 20 DO9s, 20 DO8s are in here, which these are supposedly the better of the 2879Cs. I am hard on the boat of not paying attention to the 2879C drama. The crap part has always been a crap part, and even the new design one, they're having a hard time with it. They'll eventually get it figured out to where they can schmooze it to get enough, a little bit more than enough out of it to say, okay, it's good, but it's not. We have no air going through the cabinet. The electrical's a mess, the connections are a mess, the solder work in here's a mess. I've got to take all 96 of these transistors out, set them aside someplace, And in return, here is 100 2879 16D08s. Those will actually work in this amp. This thing has the capacitance value, the wrap value, the combiner value. Everything is designed to be used with Toshiba-based parts. It is not designed to be used with the 2879C, 2879 20D09, 20D08, 20D0. I think you guys get the point. We're going to also make the amplifier taller. The combiner, I have a very strong feeling the reason that the lid is made out of plastic is because when it was made out of metal, the combiner was touching the lid. So whatever this produces, however many thousands of watts this thing is producing, I'm sure based off of the burn marks on the ferrite and the stuff I've seen going on here, the reason that we have this big of wire, because it's not really needed, this thick of insulation going on, was that it was touching the lid, was coupling with the lid was acting as a capacitor, and it was causing it to burn. I just have an idea that maybe we should take the combiner and move it back here by the relay and then have a tuned inductor so we can actually drive it down to a balanced 50 ohm load instead of some random guessed wire. I don't know. There's just a lot going on here, and I've spent a few hours looking at this, going, I don't know. I don't know if I really want to take this on, but I'm down the rabbit hole, and we're gonna give it our best shot. We're gonna have to check a lot of capacitors and a lot of components. There's literally several thousand parts inside of this box. It is incredibly dirty. So once I get all the transistors out, I think that we're going to have to do some kind of muriatic bath or something. I don't know what we're going to do to get this to come back. I mean, it is rough. You can tell that there's been a lot of moisture egress in this area. The builder that was over here, I know this person's handiwork, and it shows. Like, I mean, there is a night and day difference between here and here. So from the combiner forward has been completely rebuilt by one other person, and then from the combiner back has been rebuilt by completely another person. There has been an absurd amount of technicians in this box. So, but we're going to stop here. We're going to take a right-hand turn, and we're going to go another direction. Told you, abrupt turn. So, I got to build the Godsmack power supply, right? Like, this is absurd. Look how many switchers I'm going to have to use. I can remember a time where this big of a thing was not even a thing. Like, we couldn't have thought about doing this thing that we're thinking about doing. The thing that we're thinking about doing, obviously, is building a 2500 amp power supply, which is crazy. But 100, 200, 300, 400, you do the math, right? So I start looking at what that's actually going to take. And I have the cabinet, and I ordered all these parts because I was planning on building a 2000 amp supply, right? 2000 amp supply is totally doable. The 2500 amp supply is also doable. I've got the electrical service. It's not like I can't power this thing. It's just very expensive. Right? Let me explain. So, wire. It comes down to a wire and a disconnect issue. So, we're looking at 1/0 gauge cable is what I'm going to have to run from my 400 amp disconnect panel to here. I need to be able to pull somewhere between 150 to 185 amps. So, okay. Then I got to test and certify it. So that cable that we're talking about, oh, come on. The cable that we're talking about, 1/0, that's like no jokum wire, right? I got to go price that tomorrow, but I think it's going to be about $4 to $7 a foot. Well, I got to run 3 leads of it. I got to buy about 100 feet of it. Inside the power supply, I'm going to have to use a couple runs, either make it all out of solid copper bars, power distribution network, sorry, this is the part where you got to like hang your tongue just right in your mouth, like out of your mouth, and just, yeah, hold on, let me focus here for 1 second. The theory would be is that I'm going to build redundant supplies. Like I'll have my everyday plain Jane little supply, which I'm going to need to be able to run the driver, the radio, the workbenches. But I want to put something, I want to build something that ain't going to bend, ain't going to move, ain't going to budge. And I want the word to get out that the workbench I have here is no slouching joke, right? Now that we have the access to these wonderful things, I don't understand why I don't see all of my other fellow amphitholic crazy bastards coming up in my group, and they're telling me they're building their 1,000 amp supply, right? The wire cost, then just internally on the supply. So then that means 4/0 can carry 350 amps over 15 feet. So I'm going to need 2 runs of 4/0 gauge cable just to come up to the workbench. Then I got to build 4/0 jumpers to go from the workbench to the 96 pill. And then on the inside of the 96 pill, that means I'm going to need a minimum of 3 4/0 runs. It's getting stupid. I don't know if I'm up for this task or not, but I'm sure going to give it a hardcore run. Oh, we tripped. We did something wrong. That looks good. Yeah, that looks good. That looks good. Well, when in doubt, reset and try it out again. The other thing we have discovered is that if our little fan is not working, yeah, see, it's trying to pump up, but it's not letting it do it. I've done all of these and I haven't had a failure. I get on camera with you guys and start having a failure. It's the name of the beast. Well, that is all clean. Well, that tells me that there's something wrong with the crowbar protection then. So let's go resolder that wire. This is going to be a challenge. I like challenges, but I have to question. Oh, did I just break my tip off too? Nope. I have to question, is it going to be worth it? I mean, we're talking about maybe 3 or 4 amps in the entire United States that are 96 transistors. Don't know yet, to be honest with you. I know I'm going to give it a college try. Oh, okay. There we go. Let's try this. There we go. And we're done. The smallest error in your placement of your resistor is the difference between this is working and this is not. There's been quite a few guys that have tried to build with these and they get really frustrated because they have something just like a nano pube length out of alignment with doing this, and the supply is smart. It's got a lot of protection circuits in it. I mean, these guys at HP, they really knew what they were doing when they built these almost indestructible supplies. I have yet to have one of these give me like major shit. I've had several now though where I power them up, and they trip right out, and every single time it ends up being the fan. The fan's not turning, it doesn't have the right RPM speed, something. Every single time, fan. This situation, when I laid the resistor down, it was making the slightest contact with another solder pad on the control board. This blows my mind. It's 900 amps worth of supply. The very first 350 amp supply I built when I started in this game with an iron core transformer was so big that it took 4 of us to pick it up and put it on the workbench. 4. And now I'm sitting here contemplating and stepping and working towards building a 2,500 amp supply that I can pick up and move around by myself. And it's only going to be 5 inches, 6 inches tall. We will see. We will see. Okay. This is an old 64 pill cabinet I've had sitting here for probably about 7 years. As you can see all the different holes on the back of it. I ended up buying this from Fat Boy, 7 or 8 years ago now, and he sold it to me for really cheap. Like really cheap, like the cost of shipping plus like maybe 25-30 bucks, right? And I knew that I'd eventually have a project for it. I was going to put a big LD Moss box in this cabinet, blah 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 blah. Here we are today. I got a couple big chrome boxes over here that I could put this in, but where I want to put it is down here underneath the edge of the workbench. So there's a couple different things we got to take into consideration with this. This is going to take about 150 to 160 amps worth of 220 volts to feed this. And part of the problem I was running into is a clearance issue back here on the back of the cabinet, plus a clearance issue on the front of the cabinet. I'm going to explain to you why. One of the clearance issues that I was going to have on the back was clutter on the back of the cabinet. Now, I've already got another whole piece of aluminum that's thicker, and I got to do this for a reason. This is exactly the thickness of the face. Okay. Also happens to be the thickness of the back. So what I'm going to do is I'm going to take this piece of metal and I'm going to cut it the exact length for the cabinet, boink, and then I'm going to cut it along here along the bottom so I can utilize the vent holes in the back. Now what we have to do is visualize this thing upside down. We're going to bolt this upside down to the bottom of my bench. We are doing that so I've got plenty of space. The other thing is I want to utilize for the first time ever hot air rises, right? So I want to have the vents on the top. I got to reinforce this back plate because I want you to think about how much weight has got to be put into play, and torque is going to be put into play on the back of this cabinet. Now this thing's all cheddarfied on the back with holes. Doesn't matter, no one's ever going to see it. This is what I'm going to use this cabinet for. The other thing I've had to think about is I've got a 400 amp service coming in on the other side of the room. Well, now I have to bring 200 amps of it to down here. Well, down here is where I've got my 1000 amp supply, and over here I've got a bunch of other iron core power supplies that I'm going to get rid of. And then over here in the corner, which you guys have seen on video, I've got all of my distribution network. And then over here is my trash can. Over here is the committed 30 amp 110 outlet, all that kind of stuff. Well, I got to thinking, if I get rid of these big Astron iron core supplies that are over here, pull them out, and then put a little stand there for my computer to sit on, because my freaking 32 core Threadripper that allows me to rip 4K video for you guys in a heartbeat, I set that down on the floor. I now have a whole hunk of wall that I can bring a 200 drop disconnect box to, 200 amp disconnect box. If I can find one for the right price. I've got to bring, it's got to be 1/0 gauge copper wire for me to carry the 200 amps, the 27 feet over here to this disconnect. Well, underneath here I've already got two 50 amp outlets. One's over here that runs one of the supplies, and another one sums together and it runs this supply. It's a 1000 amp power supply, so it runs these terminals over here. You guys have seen videos on this already, so I don't need to cover that. So I have to put a new piece of conduit down here that's going to run along the length of the wall from the 200 or the 400 amp disconnect over on the wall over to here to another 200 amp sub disconnect that's going to be back in here. Well, I got a 200 amp sub drop now, so then I've got to started thinking about, all right, I can now have on yet another sub panel over here, external walled, run conduit, all that kind of stuff. Instead of having the 50 amp drop over there and another one over here, I can have all four of the drops over here. So it'll allow me to have two 100 amp drops and then two 50 amp drops. Put them all over here. I can unclutterify this space here. For me to do that, I've got to move everything that's down this wall out. It's going to be a lot. But at the end of the day, I have to bring 1/0 gauge wire into this. 1/0, like that big a wire. 3 leads of it, a ground and 2 hots. Into this cabinet, and then split it so I can feed all 20 of these supplies. That is not a small task. Okay? I don't care how you slice it, that's not a small task. So we're going to have the weight of that. Now how I'm going to do that, instead of passing it through a Heiko connector, because they don't make soft 1/0 baloney cable. They do, but it's not anything that I can get here in a hurry. And I want to be able to take this supply and go to some other place with it. Like eventually, this is all changing. I hope in this next year, if things stay the way they are, I'm going to be able to move from here and we're going to go do something different. So I have to plan on having modularity for this. So I'm going to have 2 hots and a ground bolts on the back of this thing. And then I'll have a service disconnect external to this instead of having like breakers on the back of this thing or something. I do have enough 30 amp breakers in a bag over here. I was thinking about building it like the first one you guys seen that I built like this, the 1000 amp version 1, where I put 10 of these inside of a 24 pill enclosure, and it was really pretty and everybody's like, ooh, you know. And then I had the disconnects on the back. Well, initially I was going to use, and this is what I purchased this wire for, I was going to use this soft wire, this here. This is 3-wire, what is this? 3-wire what? 4 gauge. So I guess I could do 2 runs of this This is soft baloney cable. I was going to do 2 runs of this. Well, I got enough to... Well, I got this much. This stuff is incredibly expensive per foot. And that would limit me on quite a few different things. So I might have wasted some money on this wire. I'd rather just do 3 runs, 3 leads of 1/0, come out of the disconnect panel on the bottom underneath the workbench, and bolt directly to the back of this thing. And then, you know, insulate it so there's no chance of it being an electrical short. Then I got to think about getting the possible 3,000 amps out of this cabinet up here to the workbench, which I think I've already got a plan for that. It's going to require me building yet another shelf up here with 2 clamp terminals like this. I don't know. We'll work on that another day. Okay. Today, I got to focus on just getting this done. So it's 1 step at a time. These are set up at 15.85 volts. I'm building this supply with the complete intentive purpose of being able to run 48, 96, and I guess I'd be right at the very bottom end of what 120, 24, 28 transistors would pull. We know 15.85, 15.25. We know because of the first video I made with building one of these power supplies, if I take 10 of these and I put them together like this, and the way I built the first set, the first power supply, that thing would hold above 14 volts to about 1,500 amps, 1,400 amps, right? Maxed out, it would do 1,800 amps. So there's a total possible above 13.5 volts, 3,000 plus amps worth of power supply inside this cabinet. To maintain 15.2 and above, I'll rate this conservatively at 2,200 amps maximum load. Continuous load, I would probably derate this thing down to probably 1,000 amps. So then I'd only be utilizing every one of these at half, right? But that's not the way I run things on this workbench. We do an intermediate load, duty cycle, and then off, right? So there's a lot of other stuff that I want to stick in here, and that's what I want to cover with you guys. Is 8 months ago, when this whole HP power supply thing started, I started planning to build this big power supply. In these boxes are, this is a 110 volt or 150 volt AC voltmeter. This is a 20 volt DC meter. This is another 115 volt AC meter. That way I can measure both of the 110 lines coming in that gets me the 220. I can measure each one of their line voltages. Okay. Each one of these is a 1,000 amp DC meter. Here are the shunts for the DC side of things. Okay. The DC meters work on the ground side. But what I was shooting for was the Bird 43 style meters. These will fit right into a Bird 43 cabinet. This is 2 1/4 inch, 2 3/4 inch, whatever it is, opening. Well, at that time, I don't know you guys that follow along, I went out there in the world, and can somebody please help me find a punch for 2 3/4 inch? Well, my friend Frank Beard over at Beard Amplifiers, who's a machinist and a tool maker, says, well, I've got an answer for you right here, BBI, because what I was hyper focused on was looking at Greenlee punches. 3/4 of an inch isn't really commonly used in the electrical world. I want this exact ring punch out so I can reverse mount the Bird 43s. Well, this is called a dimple punch. And Frank turned me on to this. He goes, you can use this 2 ways. First you punch the hole, and then you use this tool to dimple in the opening. Well, I don't care about dimpling in the opening. That's what this portion of the tool is for. What I care about is cutting this opening perfectly so that the meter can sit behind it, like all of our bird meters that we use in our remote setups in our truck. Well, this specific opening is what I'm looking for. That's perfect. So if we take the same tool and instead of using it this way, which cuts and dimples at the same time, they give us the other side of the tool, and we flip the tool around and we can cheat. We can use this leading edge and then this die punch and punch the opening out perfectly round. So this is called a dimple tool. The Greenlee punch that allows us to punch 2 3/4 of an inch opening, which I don't know what that would be in rest of the world measurements. Just saying. Or as you guys oversee, 1/4 of my audience, as 2 3/4 of bananas. You know, the whole world looks at us like we're crazy because we have our own measuring system. All I'm going to say is American Standard put us on the moon. Metric was never in the conversation. And it really, what it boils down to, the whole reason that we're not on the metric system here in the United States, is a certain king on a certain little island that ran most of the planet at that time sent us all the measurement tools, and that ship ended up getting sunk by pirates. So we created our own. We measure, and yeah, needless to say, this is 2 3/4 bananas. Okay. I am going to put all the way across the front of this thing. I'm probably going to have line voltage, power supply voltage, and then over here I'll have amperage with those meter shunts, which these things are huge. These took months and months and months to get. By the way, I had to order these directly from Chinesium. Even though they make another 1,000 amp meter shunt that's on these really nice bronze pedestals and stuff. I discovered those after I bought these. The reason this punch is important is because the Greenlee punch that goes to most of the hydraulic punches and stuff, they want like $400, $500 for it, at least at the time when I was doing the search for it. This dimple punch, I bought it off of Amazon, I think for like 40 or 50 bucks. So I want to give a big shout out to my buddy Frank over at Beard Amplifiers for hooking me up. These panel meters took forever to get. These took forever to get. I don't know what was going on. I know that I'm pretty sure you can get on the internet today, and these are actually still readily available. The moral of the story is this is going to be a busy little cabinet. And I'm going to put the AC disconnect switches and the breakers and all that stuff external to this cabinet. So I need you to know that going forward, so when you watch me build this, you're not going to be like, oh, look at that. No, you have to have either a 200 amp fuse or a 200 amp breaker, or you have to have. There's just not enough footprint inside of this power supply for me to achieve that with the amount of space. Okay, so let's just keep that in mind. We're going to bring the AC down the middle because the AC is in the middle. I put all of these facing to each other for a reason. The DC, we're going to do the same thing like what we did on the 1,000 amp supply, but we're going to marry it by 2. We're going to bring all the 12 volt positive and negative up here, 12 volt positive and negative up here, sum them all together. And if my math is correct, I can take 4/0 gauge wire and take the 4/0 gauge wire for both hot and ground. So I'll have to have a shunt sitting like here, another shunt sitting like here, supported somehow with a pedestal. I don't know how I'm going to do that quite yet. I'm sure it's going to involve some nylon standoffs and stuff that I'm going to custom make. Needless to say, the way I want to wire this is so I can do 15.2, flip a switch, and then boost it with a supplemental 1,000 amps worth of supply at 15.85. The reason that we're setting our voltages so high is because we cannot, if I set this at 15.85 like we showed in the 1,000 amp supply, it will hold 15.85 at 1,000 amps. It will. This will hold 15.2. But when we fully load it, everything starts to drop. So at 1,005 amps, this is going to drop to this voltage. And then from there, then we got another 1,000 amp cushion. And then from at 2,000 amps, it's going to start to drop, in theory. I did not want to set them all up at 15.5. I wanted to be able to switch on just this supply, have 1,000 amps worth of committed supply. So let's say on the Workbench in the future, not today, not with this project, but down the road, I wanted to build in some flexibility. I want to be able to have the 1,000 amp variable supply over here to run driver, you know, like radio, driver, pre-driver, second driver, third driver, whatever, and then this be a big box, or be able to run radio and driver sections and then have this hooked up to the big box, 32 pill, 48 pill, whatever, 24 pill. And I want to be able to loaf at 15.2 and not tear anything up. But then if I have to, I can hit it with 15.85, getting us really close to 16 volt, which we don't really want to go past, and have another 1,000 amp cushion, aka boost. So we're going to build this in stages. We're going to make this so that this switches off, that switches on. That is going to put these power supplies in the state where the fans will go at a high RPM though, without isolation. I didn't think about that last night when I was setting this up. I might have to pull all these apart again. It's okay, at least all I got to do is change one resistor. What I did on these to make sure that the crowbar protection is almost nulled out on both of these, right? I've got a 5K resistor instead of the 9K. I got 5K resistors on both of these. So short of a dead short, all of these supplies will keep running no matter what. We know this, we tested, we took the load cell, hooked up one of these things and ran it to depletion. I literally took the crowbar protection circuit and put a wire on it. Solid wire, no resistor whatsoever, and ran it. These things will produce about 150 amps for a few seconds before they really start freaking out. They easily do 150 amps a piece, but the voltage drops off pretty steady. 100 amps is where we know these things run really well per unit. So depending on how you want to slice the numbers, we're going to be pretty solid at 15 volts, 15 point, and now that I pointed this out on video, I got to go back and open all these up. I'm going to redo all 10 of those. Son of a bitch. We're going to be rock solid at 15.8 up to 2,000 amps. At 2,000 and 100 amps, we're going to be at 15 and on down. This is going to be more than enough to run this 96 pill, I think. I feel. I believe. I'd like to believe. I'm telling myself and telling you and trying to convince you as well. God, I didn't even think about the fan issue. The fan issue that I'm talking about is if you have 12 volts going to the back of one of these supplies and you do not have 110 volt or 220 going in here, the fans go into auto cool mode because they think the circuitry defaults and it says that the fan or the amp has gone to crowbar. It's gotten too hot and it's gone to crowbar. The power supply, not the amp. The power supplies have gone to crowbar protection and they default to full RPM speed, which is really annoying times 10. This would be so loud I wouldn't be able to shoot videos and hear it screaming underneath the Workbench. So this has to be all on or off, or I have to isolate this section from this section with 1,000 amps worth of contactor. Yeah. That's some big contactors. Or a whole bunch of little ones all tied together, which is very lossy. I think we're just going to have to live with the fact that we're at 15.85. Which is fine, because as soon as, yeah, we'll be fine. It's going to be fine. Yeah, okay, moving on. That's what we're doing. So when we hop back, these will probably be bolted down, and I'll have a giant spaghetti mess in here because I'll start wiring this thing. But when we're done, it's going to look really, really pretty. And we'll have two switches on the front with an on LED indicator. And we'll see if we do some LED magic with these. We'll see. this is gonna look nice. So I used the dimpling tool and it worked out perfect. I want to say thank you, Frank over at Beard Amps, for hooking me up. Look at this. The older I get, the more I recognize I could have made this with 10,000 colored LED elements. But instead, I opted for warm white. I'm getting older. Eyes are getting a little weaker. I just recognize that this is going to be the last power supply I ever have to build, right, for myself. Really going to try not to build any more for other people. I got a couple more in the pipeline, but that's it. Needless to say, I'm excited because let me just say this is the last of the last. I'm building this one for me. No, it is not for sale. So I went ahead and instead of setting the meters completely flush I did what they call recessed stepped back. So we recessed the meters, set them behind, and then I put the distance of one bolt length worth of 632 bolts with star washers on it, set them back. And I did that so I could have backlighting around them. That looks excellent. These Chinese meters, just by chance, happen to have this ring system on the inside that keeps the back of the meter supported, and it just floods it out just perfect with the right amount of light. So we'll say when it's underneath the workbench, it's going to have about, here, we'll just turn the lights all the way off. Look at how it backlights those meters perfectly. So even in the dark, you can read it perfectly clear. And it's not enough to like strain your eyes. Like if I made this blue, and I know this from, well, a previous thing that I built. Let me show you what I'm talking about. These are my bird meters for my own station. Now when you're looking at them straight on, they're really easy to understand. And I cannot stop down the ISO gain low enough on the camera to get those to where they'll be clear. Blue is really pretty. It's also very hard to see down at an angle. So just keep that in mind. I did this for a reason. That's obnoxiously bright, those blue lights. So this is how I work most of the time. I got a bunch of lights that I turn on for shooting. And yeah, that's how far I had the gain turned down on a camera to try and bring those into focus as far as brightness goes. That's perfect. That's just the perfect brightness for in here. Remember, building this for me. Here, that's all the what I call studio lights on now. Perfect. Boy, there was a lot of measuring that went on here. Let me tell you. Measuring of the spacement between these 3 meters, the measuring of where to place the screw holes. I got to give my hat to Charger for making this easy for all of us. It's to handcraft this with nothing but a ruler and a pencil and some blue tape. This is a little bit of a challenge to get this all perfect. And yeah, you'll notice we're even taking the detail, like Phillips head screws are all orientated straight up and down. Even the nuts on the front of this thing. So how this is going to work is this is going to be power on. This is going to be fan boost, the center switch. And then that far one's going to be lights for the meters. So I can turn the lights off at any time. And then I'm going to do probably 2 120 millimeter fans on the inside of this. For filming, I have to be able to turn the fans off, right? But then as soon as I'm done filming, I have to turn a coolant fan on cool down the power supplies on the inside. Believe me when I tell you, noise discipline in this room, I'm pretty serious about it. Once again, I want to remind everybody that we're going to mount this upside down. So this technically is the bottom of the cabinet, but we're going to bolt it up underneath here. And I'll probably put the ass end of it down at a little bit of an angle to make it a little bit easier for me to see it from the front here. So this is, ooh, I'm excited about this. I'm excited about this. Okay, now to actually do some real wiring on the inside. Let's get the modules in this, because right now this is just an empty hollow cabinet. I've got most of my pre-drilling done. The back of the power supply has now been reinforced. I'm ready to start hanging the modules in it and start thinking about management on the back of the cabinet as far as positive, negative wires. I'm ready to start fabricating stands to hold meter shunts and that kind of thing. This, though, I am beyond excited about. This makes me giddy almost. So here we are, a full day later, and as you can see, we're coming along quite nicely. I was telling you guys that it didn't really matter about the back wall. Remember, I was talking about the whole thing is going to be Swiss cheesed. It was Swiss cheese, the cabinet. Well, I always had an intent to reinforce the back of the cabinet here, which we did. We put a brand new piece of, I think, 60-31 or 60-30 aluminum across the back. First thing we did was beat all the wobbles out of it, right? But I'm planning on having like DC hot, DC ground, and this is where my 2 AC leads are going to come from, right? And this is going to be our common, our green, you know, our ground, I mean, return, neutral, however you want to put it. What I'm visualizing in my head now are the next steps, which we've got to build this in layers. And the other thing I got to think about is that this thing's going to be hanging upside down, right? So, I mean, like right now we're looking at it, this is the way it's going to hang. So solder joints only get us so far. If this was sitting flat, I would have a lot less concerns about it. But since we're going to be hanging it upside down, and the parts from this point just get really big. Like, here's our meter shunts, right? These parts are going to get heavy fast. So the first thing we have to do is we've got to build it up in layers. I got to bring in my AC lines from back here. Bring in my AC lines back here. And then I have to create a distribution bus that's held together with hardware down in here someplace. I'd like to put it somewhere right in the middle. Then from there, I'm going to take a solid copper bar and go across from here to here. But I have to have things bolted down. Like these meter shunts are really heavy. So if I take and let's say solder a copper bar across here and then bolt these to the copper bar, like so, I have to support the weight of the shunts so they're not pulling against just the solder joints here. Because remember, this phenolic is held on with a little bit of glue, right? So that long time torque load is going to have a problem. Well, same thing goes for the AC line underneath. It's a lot of weight to support. 2 pieces of aught gauge coming in, plus we're going to have the weight of the 4-aught wire. It's going to be for the positive and the negative terminals. The other problem we're running into is there are about 8 places here in town that I can go get bronze hardware from. Bronze bolts, bronze nuts, bronze. I want it to be all bronze. You know, steel and stainless steel passes current to a certain point, and then we just reach a point where the electrical resistance is just going to be, it's not worth it. So people like to use brass. Problem is brass is not as strong as bronze, but then the two electrical differences are not that great between brass and bronze, right? I mean, if it was up to me, I'd have a continuous run that came out the cabinet, but I got to build this to be modular so I can move it. Like I said earlier, I'm planning on not being here forever. I want to move this to a different location. So, needless to say, we have to think about this for a little bit. The 110 or the 220 volt lines that go to each one of the supplies, I can solder those in place, but the 1/0 gauge cable that comes in here to feed that, I have to bolt that plate down and then bolt the 1/0 gauge to that plate, so we're not suspending that weight. And the same thing with the ground bus, which if I took a piece of, like I said, solid copper and went between the two, and then hung the shunts off of it. I mean, I guess I should have planned this differently and put the ground distribution up here, up towards the front. Just too late now and I'm not redoing this, so. Then I hung the two shunts off that. So then from there I got to drill a couple holes in the shunts, and I got to hang that on a piece of plastic or something to help support all the physical weight of these, right? So, just thinking ahead a little bit. Whoa, just pulled my mic off. Sorry about that, everybody. Trying to think ahead a little bit, but this thing so far is all sexy on a stick. Wonder what happened here. Two little feed lines got a little whoopee in them, you see that? Well, hopefully I didn't rip the traces off. I'm not going to lie, the tying of all of these together with individual little pieces of wire and something, that's a mess. So what I did on these is I took and soldered on a little piece of like 16 gauge wire and then laid another piece of wire on top and then soldered that in place. This seemed like that was the easiest thing to do. And then I can just grab up here on this terminal in here and then grab up down here as well. Then all I got to do is run two wires over to the on-off switch. So on, fans, light. Let's see, so we flip it over. On, fans, light. There we go. Gotta think about it. Anyhow, good morning. Day number 2. I don't know. I got myself in a groove and I didn't stop working yesterday for anything. So this is actually day 2.5, almost 3, but it is what it is. This thing turned out pretty good. This is high temp, fairly thick fiberglass, which should be easily able to support the weight of the hardware and then the weight of the big ass wires that are going to get attached to it hanging from it. So, and I'm thinking what I'll do is I'll have 2 positives, 2 negatives or whatnot, and then I'll have bars. So I'll drill a hole in one, like a solid copper bar. I'll drill holes in one side and then cut a notch in the other piece so I can flick it over. I'll probably have it so gravity's working for me. I can flip it over, you know what I mean, and tie the two together. I just got to remember, if I tie to this one, it means I got to tie to that one. If I tie to that one, that means I got to tie to this one. That way I'm pulling across everything. The same principle is being applied here with the positive and negative wire. So you'll find that the wire that goes from here to this supply is the same length of wire that goes from here to this supply, roughly. So electrically, as far as anything is concerned, all of these wires are the same length. So we're cheating. We're making the wires on the positive side shorter, and then on this end of the supply we're making the ground wires shorter. So electrically, everything kind of arrives at the same place at the same time. We do the same thing on this side. This wire here versus this wire here. So then this long lead here goes to this power supply. That makes sense? And then this long lead here goes over here. So one's shorter, one's longer, but when we flip it, it's the opposite way around. So in theory, everything has the same length or sees the same amount of load. Because now we're pulling across these two supplies, that's simultaneously pulling from the center ones. That's the theory anyhow. And it so far has worked in the last dozen or so of these I built. So yeah, needless to say, that's where we're at. I'm not gonna continue on. When we come back, the 220 volt lines will be in and all of these will be tied up. So we'll have all of our 240 volt lines in, and then we'll have our two 1/0 gauge cables coming in, and we'll bring them down to some kind of distribution plate. Damn it, did it again. Sorry, did it again. I will find, I've got some really thick phenolic. I got super thick compared to what we normally use. It's almost 3 times the thickness. I'm going to use it to solder to, but my 1/0 jumpers that come in, they're going to be hardware and stuff that bolts to the eyelets that have been, I've got to have a physical connection. I cannot just rely on a solder connection. They'll end up causing problems. And from this point forward, from here on, we've got to have soldered connections. I mean, mechanical connections, along with soldered joints. The pressure to hold everything together and keep everything in place. Just in case, let's say we have a connection over here that isn't quite as good as the connection over here, and this ends up getting really hot, and the solder ends up boiling out of the way. Okay, the solder falls on the lid, but the bar doesn't fall off and causes us to have a short and a fire. Got everything held down, and the pressure is the number one thing with making a good joint. All right, we'll be back. This did not turn out how I initially pictured this in my head. It just didn't. So initially, I'm not gonna lie, I had just this bank of 5 I used as my test subjects, right? And I used about 7 million zip ties, and I did this same organization trick on all the power wires, the positive and the ground and the other positive, the white and the black and the green. And it looked really pretty. Then I went and I did this side, this 5 of the supplies, and I realized that it was going to become incredibly cluttered inside of this thing. It took me 4.5 hours to wire this side and about another 3.5, 4 hours to wire this side. So I was figuring, well, another whole 8 hours to wire this side, and it would still look like a zip-tied cluster nut mess in this thing. So I said, okay, I cut all the zip ties out, and working off of that platform, I went ahead and I just brought everything so it has the same length. So the black wires here that are fairly short, the white wires over there are fairly short, but then the white leads off of the black leads are long, the longest on this side. It's the same thing. It's the same game that we're playing. So roughly, and then in turn I have to think in like the 5th dimension of thought, right? How far away is the lead from the 1/0 gauge power wire? Yes, by the way, these are my power leads coming in the back. This is how I'm going to hook up the 110 volt on the outside, or the 220 volt on the outside. There's going to be a third hookup here for the case ground. This is how I'm bringing the power in the back of the cabinet. It's 125 amp. Well, 145 amps. I'm thinking 150. I looked high and low on the interboob, and I'm out of time. So normally I would try and get some soft, flexible 1/0 3-lead copper baloney cable. I know the thing is made. No one here in town has it, so I'm going to have to just go with having a disconnect panel and have a little bit of open secondary, which I'll in turn create some kind of insulator for back here on the back of the cabinet. I'm excited because we're finally at the point now where, like, this portion of the whole thing I hate. I hate wiring this kind of stuff. I could never ever sell this thing into the public wired like this. There's certain standards that I would have to convert this over to. I'd have to have, oh shoot, I seen a whole bunch of them the other day. I'd have to have strips that are all tied down, and I'd have to have crimped eyelets that are all soldered, and then I'd have to create a bus bar, and I'd have to bring, so that'd be what? On this side of things, 30 leads. On this side of things, 30 leads. So 60 total wires I'd have to manage. That's not a big deal. Then the jumpers that go from each one of those, an additional 60. Then I'd have to have subs and then sub distribution bars to come from aught down, because they don't make an aught to, so I'd have to go from like an aught distribution to like dual sixes or tri sixes per leg. I can build this for me as the home gamer. If I was contacted by one of you guys to build you guys, let's say 1,000 plus amp, 2,000 amp supply like this, I'd have to do it on a different level, right? I'd have to probably not have such a small cabinet, and I would have to take, definitely for sure on the 100 or 220 volt side, different management style of how to manage the power distribution and how it's secured. This is soldered and bolted down, so even if for some reason these leads get so hot that the solder somehow manages to drop, see that right there is a big no-no. I'd need a pressure bond connection that was mechanical in nature to terminate these properly, then have those lugs then be bolted, and then everything that's attached to it also be bolted, right? Just makes sense, because if the leads get hot, we don't want the wires to wander, fall off, come disconnected. Me, the way I'm going to use this thing is going to be on and off. The hardest that this thing is ever going to have to work is the test that we're going to put it through when it's done, right? Because we're going to beat the schnooky out of it. We're going to beat the schnot out. A soldered connection on this side of things is not the wisest decision in the world, but this is what I'm working with today. If I had a little bit more time to plan on this, I'd wire it differently. So do not use this, I'm saying this to all of you guys on YouTube land, do not use this as a blueprint of how to do this job. The 220 volt wire management, it is not that. It's not that. Okay. Yeah, it's just not that. So the next steps we get to do is, these are our positive and negative wire distribution terminals that we're going to utilize on the back. We're going to use big ass. This is the biggest and the longest bronze bolts that I could get at the one place I went to, which was just Tacoma Screw out here. We know that the smaller bolt than this can carry 1,000 amps, so I figure two of these will easily carry 2,000 amps. We're gonna create shorting bars that are scooching heavy duty. So we'll have one of these. I've decided we're gonna put this on the inside. So it's gonna be positive wire, positive wire. We'll make these the same length. So in theory, the current should go across both banks, right and left banks. Should get pulled evenly. We'll have it terminate on one nut, and then it'll have this copper bar to carry the current to the next nut to it. The same thing's going to happen with the ground side, which I think I'll put over there. The two leads are going to come off the meter shunts, so I have to attach like here and then come over off of this side of the meter shunt. So we're presenting the same amount of electrical distance, and we'll have to route that around our 4-aught wire that's going to come off of each one of these. So it's going to have dual 4-aught leads and then dual 4-aught leads. Does that make sense? That's the reason we have to have the distribution bus in the back. So we've got one 4-aught lead going, it's going to go over there, another 4-aught lead that's going to go over there, and then one 4-aught lead that'll come off of here, or no, pardon me. This is going to go there, this will go over there. One 4-aught lead that comes off this side of the shunt, and then another 4-aught lead that comes off of that side of the shunt, plus the weight of the wire. So we look back here and these little pieces of all thread, 632 all thread, that are supporting these stands up and away and holding the shunts up in the air. Now we got all this weight hanging out in free space, and this little piece of tiny phenolic, I don't think that that's going to quite do the job. So I have to create some kind of support bracket. That's what I'm going to work on next, to help support this end of the shunt, to help support the weight. And remember, all of this is going to be flipped upside down, so what you're looking at now as top is actually going to be the bottom, if that makes any sense. So the support bracket's going to run from off of this end of the shunt somehow down and attach to the cabinet. What I'll probably do is I'll probably take a piece of nylon or Dowron or Teflon or something and go down between these two plugs, and then I'll have a piece of phenolic that I'll bring back. So I'll screw to the support stands, and that'll help support the weight of the shunt and also help support the weight of the wire. 4/0. Big wire. So I am going to go work on that. The other part that we get to wire up, which I'm all excited about, is all the fancy trick meters in the front. Get to tie in our 2 amp gauges, or 2 volt gauges. Everybody's like, well, why'd you get 2 voltmeters? You should only get 1. I'm like, right, yeah. Or maybe I want to look at the voltage. The guys are laughing at me. They're like, you should only get 1 voltmeter. You don't need 2. You didn't know they made. You didn't. I had one guy goes, ha ha ha. You're a dumbass. You didn't know that they make a 220 volt meter. I'm like, yeah, they do. Or maybe I want to look at 110 volt off this leg and 110 volt off this leg. I want to look at both legs. So when the voltage drops, I'm going to be like, oh, it's dropping on my white lead. Or, oh, it's dropping on the black lead. And know that I've got a problem on that one particular leg of the 220. I can take the combined voltage of the 2 meters and put them together in my head. Just saying. So this is our AC volt. Over here is AC volt. 110 volt, 110 volt. I thought it'd be trick. That's why I did it. Once again, I'm building this for me, not for anybody else. Our combined total amount of voltage on the 12 volt scale, and then over here is going to be our amps. So this one will go to this bank, and this one is obviously going to go to this bank here. And I was also thinking about why I had this, maybe putting like a 5 or 6 prong mic jack, like coming out of here, out of the bottom over here, so I can remote all of these meters. So maybe I want to call up my buddy at over at Fat Boy over ICA and have them make me, instead of a triple beam, do like a 5 beam. What I mean by triple beam is they make these cute little metal boxes that are all punched out like this. I did all these by hand though. They make one that's got 3 windows on it, so you can do a voltmeter and forward and reflect, or do a forward and reflect and then a reflect on your driver or whatever. They make 2-stage ones, right? But I want to get one that's one solid unit, and then maybe put it up here someplace, or up here or over there or something, so I didn't have to look down. I could look up to see it. I might pre-wire that in, but I figure after we get our eyelets with our wire, our bolt, so then we're going to have another nut to hold pressure on everything, lock washer. I like to have long leads on the back of my power supply, so let me show you what I'm talking about. I like to have the bolts be long, right? So we're going to have our bolt, our eyelet, then we're going to have our shorting bar. So we'll need a washer. So we'll take a washer and put it in this equation, right? Then a nut, and then the actual fiberglass thickness, then another nut, and then we're going to have yet another shorting bar on the outside of that. So here, once again, on the outside, then another washer, then another bronze nut to hold that in place. And then from there, then we get 2 washers and another nut. So after it's all said and done, this big long bolt, you know, we've only got like this, like a finger's width worth of thread left. Saying, planning for the future, right? So, okay, on that note, I'm going to get some stuff going here. We're going to get some things wired. We're going to get some switches wired up, and we are going to get this thing turned on and get voltages tested and see what modules turn on, and if some don't, and if we have problems, we're going to diagnose those, but that's where we're headed. When we get back, there's going to be a big ass power wire in this thing, and we're going to be talking about powering it up and getting it going here. This thing is becoming absurd. The longer I look at this, the more absurd things get. But it is what it is. I'm questioning several things here. I wish I could have more surface area and more metal mass coming off the shunts. I'm just going to say that right up front. Depending on how it goes in testing, I've got a little piece of fusible link here. You know, 4,000 amp fusible link to bridge the 2 shunts together, but I don't think I'm going to need it when you see the backside. I put the Teflon around the ground wire because it's right next to one of the 220 leads. It is clearing, but by like that much. So I'm in that point now, and from the beginning of this I had to think about, well, if I have a problem with this, I drop the lid, then I'm laying on my back looking up at this thing, right? Hence the reason why all the nuts and the bolts are faced the way they are. Like if for some reason this manages to make its way loose, just the nut falls off, the bolt stays in play, and maybe the wire will stay in place. Think like that. There's a reason that all the connections are on what would be the bottom side of things, so I can just reach up and unplug, right? If needed. Just got to make sure I haven't damaged anything in my moving this thing around. Let's go around to the back side here. Here we are on the back side of things. So we created these copper bus bars to sum the positive and sum the negatives together at the output, give us a little bit more metal mass too. I really don't want to add that fusible link, because then with the use of this I can simply break the connection and run on one bank if needed. The idea to be latch these down and tighten this up so that they don't come undone, and once again several thousand amp link. Same thing comes into play over here on the positive side. This is whole, so I can drop this and leave it hanging. Oh, for the love of Pete. Of course, on video always. Feeling pretty confident about this. This is looking really good to me. Yeah, the only thing left to do now is to wire up all the meters. So it's pretty simple. So we got a meter shunt for volt, meter for volt. So I go down here and I tap one off ground. So I'll probably grab a ground over here on the side of the case for the cabinet. And then a probe wire that goes there and a probe wire that goes there. Then our 12 volt side of things. So I'll probably grab, like, let's say hot here and ground over here, measuring across the 2 supplies. And then wire in our meter shunts, tie our wires on for the on and the off. Tie our meters on for the or tie the switch on for the fan, so give it a 12 volt hot. And LEDs also shared 12 volt hot. So Probably take power wire, loop it over, go to this meter, then take the 12-volt lead and go to those two switches. So it's very straightforward. We're at the very end of this thing. And you guys are going to laugh when you see how I hooked this up at first. This looks silly to me. This is like asking a fire truck to put out a fire through a fire hose, but it'll be enough to get this thing tested. That's 4 gauge on some crappy disposable eyelets I don't care anything about. There's enough voltage and current there for me to be able to at least test my line gauges, turn the power supply on, put enough load on it to make sure that the meter shunts are wired properly. So we're gonna roll with it. That's cute though, right? And then even to add more laughter to it, it's hooked up to a 50 amp plug. Which reminds me of most of my CB buddies trying to run a 10,000 on a dryer outlet. So, yeah, needless to say, this is woefully inadequate. Tomorrow, late in the day, I get 50 feet of 1/0 gauge copper, and I get 25 feet of 1/0 gauge green. So we can wire this properly going forward, and then we can do a full massive test. We'll probably do that in the second portion of this video. So, needless to say, this is all hooked up. These lugs are all tight. There is 220 volts live on those connections at this moment. Let's turn it around and let's see what happens. Well, we're looking good. Power supply volts and our line voltage is looking good. We're sitting about 120, 110. Of course, you got to remember we're upside down, so the meters aren't necessarily moving the way they should. Like these are hanging, showing positive amp draw. There is no amp draw. It's just simply the way the power supply is sitting. So let's see if we can get this all framed up. Okay, so let's turn power supply on. I've never hooked this many of them together before, so I don't really know what's going to happen here. Turn the meter lights on, make it a little bit easier for you guys to see. Hold on one second, I want to check something. Okay, let's start again. At least that was easy to figure out. I mean, legitimately that was easy to figure out. So let's see here. Let's put some load on this. There's about 500 amps. Yeah. It's over 1,000. Whoa. Whoa, let's look at that. Let's have some fun with this for a second. Look at this. On the stop peg, look at her voltage. What's the meter on the front say? I mean, that's... I see another phenomenon going on, or hear another phenomenon going on here. Hold on, we'll pull some more load on it. It just makes 1,000 amps like it's nothing. Look at our voltage sag on our line. It's not even present, really. Okay, so I don't know if it's coming across on camera or not, but every time I hit this with a heavy amp load, this screwdriver is tapping against the cabinet because it's getting sucked up by the electromagnetic field that's going through the supply, or through the lines to the pile here. That's 1,000 amps. That's awesome. I'm going to need to buy another one of these, I have a feeling. Wow. Wow. I'm tickled. have to be very careful what I'm doing here, because once again, I got 4 gauge going back to the cabinet. It calls for 1/0, and then it's going to a 50 amp outlet that's wired with, I think, 6 gauge. So 6 gauge. So this thing is really starving for current coming in. And the fact that I was able to pin both these needles almost in the corner with only a 1000 amp pile is impressive to me for the pile's sake. What is scary to me is that this power wire in spots, I've been off the hammer now for a couple minutes, was at 285 degrees, and I don't know what the melting temperature of this jacket is. I don't want to find out. So it's working. Everything's working just the way it should. All the power supplies are turning on. And by the way, I want to point out one thing. All of the on indicator lights are off except for this one. For this one, for some reason, is the control unit. I don't understand how it all works, but we're obviously able to get the current out of it because, well, I mean, there's 500 amps like it's nothing. Check this out. Can't tell me there's not electromagnetic current going on here. And I gotta stop. As much as I want to continue, I gotta stop. I'm gonna end up seriously causing some harm. Either I'm gonna have an electrical fire, one of the 6 gauge lines or something. So this is where I let everything cool off and I back away from it for right now, but tomorrow's a different day. Yeah, 195 degrees. It's hot, very hot to the touch. What I think is cool is this connector here is 87. This solder joint's 87 degrees. And this solder joint here is 82 degrees. And that one is 91. And that one is 87. So I'm happy. I feel very safe about this now. I was a little bit concerned about these connections. Very concerned about these 2 connections here. Yeah, so that's 84. And that's 80 degrees. I was a little worried about these making good contact with the solder underneath them, but they're not even warm. But I am going to have to put some scooching fans on things to keep things cool. Our power wires are about 90 degrees, 88 degrees, 82 degrees, 74 degrees, 78 degrees. So we're chooching. I'm excited. I really am. Well, gentlemen, this is where we're going to cut off the part 1 video. I got a couple days. It's going to take me a couple days to rearrange everything out here, get the power wire run, get this thing mounted, get the lid put on it, get the fans installed, all that great stuff. Tomorrow I got to go buy plastic to put over the fan holes I'm not going to utilize, that kind of thing. This is where we're going to tie this up. I want to give a big shout out to Hopping Around, who's allowed all of us to be able to build big power supplies like this. I want to put a big shout out from MechMan, Siglant, Coaxial Dynamic, Bird. Penta has been my hero this year. Penta has sold so many tubes into the radio market this year, based off of the videos that have come from here. Those guys are my heroes. They are literally attempting to save the hobby 1 tube at a time. So if you had an opportunity, go check them out. Go check out Penta Labs. If you call them, you're gonna ask for online sales. Okay? Ask for Scott. Tell him I sent you. He's going to take good care of you. Scott's a good dude. They usually ship within less than 24 hours, and their packing is top notch. Also want to point out to everybody that my friend at Big Rig Radio, Zane, has moved locations. He is no longer at the Danny's truck stop. He's moved up the way, and he is getting ready to open the largest online repair center for CB radios in the world. He's geared up now. He's going to close down his storefront portion of the business, and he is going to be moving towards doing Nothing but internet repairs. You mail him the equipment, he repairs it, he sends it back. He's got 5 technicians working for him now. So that means your turn time isn't going to be months, it's going to be literally days. So more on that to come in the next video. Gentlemen, on that note, I'm going to run away. I also want to give a big thanks to our Patreon supporters, these guys here. If you have not thought about subscribing, I really wish you would. It is what makes the world go round, and they are what fund these crazy ass wild projects like this. They're also the ones that allow me to have the maneuverability to move around and go do all the interviews that you guys enjoy. I know the last one, numbers are a little off on that. It only got 10,000 something views. Still, that's 10,000 radio operators that were interested in the subject that I talked about. Thanks for the views, thanks for the clicks, thanks for the thumbs up. Moving on. Gentlemen, I'll be back with part 2 in just about a week or so. I'll see you. Click, click. A little side note as I'm cleaning up here. These cables are permanently bent in this position, and you can see everywhere where I had the cable laying across itself. Yeah, we've got rubber deformation on the wire. The PVC jacket is melted. So I can't have nice things. I'm just hard on stuff.